Welcome back. In our last module, we're going to talk about when a radical equation has no solution. So what I want to bring up is the concept. We started reviewing how to solve linear equations. Linear equations always have one solution because a linear equation is degree 1. And we didn't really have to check it because you're guaranteed if you solve correctly, that solution should check. So a linear equation always has one solution and it always works. When we learned how to solve quadratic equations, we know quadratic equations are degree 2, which means we're going to get 2 solutions. And we talked about how you really don't have to check because those 2 solutions should always balance the original equation. So linear equations and quadratic equations, you do not have to really check the solutions. They should work unless you made a boo-boo with your computation. But now we're talking about rational equations and radical equations. In the previous modules, we saw a rational equation is a fraction, and a fraction contains a division bar. And if you wipe out that division bar, when you multiply by the LCD and you wipe out the division bar, you're changing the equation to be either linear or quadratic, which means when you have a rational equation, you're not guaranteed your solutions, your answers are going to check, because we had to make sure those solutions did not make the denominator 0. The same thing's true with a radical equation. In solving a radical equation, you're wiping out, you're getting rid of the radical, the root symbol. And when you do get rid of the root symbol, you're making the equation either linear or quadratic. Again, because you're wiping out a symbol, there's no guarantee the solutions you're getting are truly the answer. That's why with a radical equation, you always have to check. So, everybody look at my simple radical equation in the PowerPoint. Square root of x equals -2. Real simple one. We know it's a radical equation. It has a root symbol. Your job is to isolate the root, square both sides, and then solve. Well, step 1 is done. The root symbol is isolated. On the left side is the root, and on the right side is your value. So we're going to go right to step 2. To get rid of a square root, we do the inverse operation. We square both sides. So if you look at the PowerPoint, I squared both sides. On the left side, a square and square root cancel out. That's why we have good old x on the left side. On the right side, if we take -2 and square it, -2 times -2 is 4. So we did our process correctly. We solved, we got an answer for x. There's no guarantee that answer is correct. When you're solving a radical equation and you get an answer, there's no guarantee it's correct until you physically check it. When you check, you go back to the original equation. So if you look in the PowerPoint, I have the original equation written. Square root of x equals -2. I'm going to substitute, replace x with the answer I just got, which is 4. So now I have square root of 4 equals -2. When you check, your goal is to get the left side to equal the right side. Well, on the left side, we still have an operation to do. It says square root of 4. Well, what is the square root of 4, guys? It's 2. Does 2 equal -2? No, it does not. That shows me the answer you got for x, the 4, does not work because it doesn't balance out the equation. If it doesn't work, we have to take x equals 4 and throw it in the garbage. It's a useless answer. And that's what's going to happen in real life. There are things that happen you have to throw out. They're useless. When we throw out x is 4, we don't have any other answers for x. And this is what we do. When we do not have an answer that's going to make the equation balance, then we say there's no solution. There is no number you could square root on the left that's going to equal -2. I don't care how hard you try. There is no solution to this equation. Okay, let's go to the whiteboard for the last time.